All right, so we're looking at section 5.3, and we're going to be talking about solving polynomial equations. All right. So we're just going to start with this first example where it says, what are the real or imaginary solutions of each polynomial equation? So in this case, we have this polynomial equation. The first thing we want to do with this particular problem is set it equal to 0. So that means we've got to move the 3x to the other side. So that gives us 2x cubed minus 5x squared minus 3x equals 0. For this one, we're going to try solving this by factoring, which means we're going to have to do two different forms of factoring. The first thing we're going to do is we're going to factor out a GCF, and then we're going to see if what remains can be factored from there. So in this case, we're going to say every term here has an x in common, so we can factor out an x. So we're left with 2x squared minus 5x minus 3 equals 0. So what we want to do now is we want to go ahead and factor this, what's left over in the middle. And we can do this using slide divide or factor by grouping. This is a good practice for factoring, so let's just try factor or slide divide. So we'll slide this back. So x squared minus 5x minus 6. Two numbers that multiply to be negative 6 but add to be negative 5. Well, that's easy. It's negative 6 and positive 1. But because we're using slide divide, we now divide by our leading coefficient, which is 2. And so the factored form here becomes x minus 3. This comes back out in front. So this is 2x plus 1. And then we bring down the x from before. So this is our factored form. All of that set equal to 0. So now what we need to do is we need to take each one of these quantities and use the zero product property and set them equal to 0 in order to solve. So for the first one, it's just x equals 0. That's easy. For the next one over, we've got x minus 3 equals 0. We'll add 3. So x equals 3. For the next one, we've got 2x plus 1 equals 0. We'll subtract 1, so 2x equals negative 1. Divide by 2, x equals a negative 1/2. So these are our solutions. All right, so here we have 3x to the 4th plus 12x squared equals 6x to the 3rd. We're going to approach it the same way as the last one, but this one's going to end a little differently. So what we're going to do is we're going to start by bringing the 6x to the 3rd over, so we'll subtract it. So we should have 3x to the 4th minus 6x to the 3rd plus 12x squared equals 0. We could make this problem a little easier by factoring out the greatest common factor of the three terms, which in this case is going to be 3x squared. So that's going to give us, it's going to give us x squared minus 2x and plus 4. In this case, I would look to factor what's in the parentheses, but there aren't two numbers that multiply to be 4 that add to be negative 2. So I can't factor this. So then I have to resort to a different method of solving, in this case, a quadratic. I can use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac, all of this over 2a. And so I'm going to solve this. All right, so I'm plugging in my values. So I'll have, we'll just go ahead and do it right here. So my b value, so this would be 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 4. All of this over 2 times 1. Well, this is going to simplify to 2 plus or minus the square root of, this is 4 minus 16, so this is negative 12 over 2. Well, I can simplify that even further. So this becomes 2 plus or minus, and I'm going to reduce my radical, which in this case would be, so let's take it here, square root of 12. We know it's going to break down into I square root of 12, which then breaks into I square root of 4 times square root of 3. So that means we're going to have 2I square root of 3 over 2. Well, that can be simplified because this is divisible by 2, divisible by 2, divisible by 2. So we end up with 1 plus or minus I square root of 3. This is two of our answers. And then if we think about what we have here up top, we go back and we solve this. We had the 3x squared equals 0. So 3x squared equals 0. Divide by 3, it's still 0. X squared equals 0. So x equals 0. So our solutions in this case are x equals 0 and x equals 1 plus or minus I square root of 3. So we have one real solution and two imaginary. So here, if you want to go ahead and give these a shot, you can pause the video, try them on your own, and then see what happens, or you can just kind of follow along. I'll work through these real quick. So here, this is already factored for us, so we're just going to set this equal to 0. We could factor the 1 down more, but we don't need to. We can use the square roots to solve this. So here we'll add 1, so x squared equals 1, so x is going to equal plus or minus 1, because the square root of 1 is just 1. Here we'll go ahead and subtract the 4, x squared equals negative 4, square root both sides. You've got x equals the square root of negative 4, which we have to simplify down into, which in this case is going to be I square root of 4, which then becomes plus or minus 2i. So these are our two sets of solutions there. Here in this example, we'll want to rewrite it and kind of follow along the same way as we did before. So x to the 5th, bring over the 5, that's minus 5x to the 4th, add over the 2, that becomes 6x to the 3rd equals 0. GCF in this case is x to the 3rd, so we're left behind with x squared minus 5x plus 6 equals 0. You've got x to the 3rd out in front still, but this factors down into x minus 2, x minus 3 equals 0. So your solutions become x cubed equals 0, which is just x equals 0. Here we've got x minus 2 equals 0, which means x equals 2. And then x minus 3 equals 0, so x equals 3. Here we come across a concept summary for the various ways for polynomial factoring techniques. A lot of these we've seen, factoring out the GCF we've seen, quadratic factoring, perfect squares we've seen back in 4.4 and 4.5. Difference of squares we saw in 4.4 as well. Factor by grouping, we actually used this in 4.4, but this is an extended version. And then we have the sum, and this is the big one that we're looking at right now, the sum and difference of cubes. So we're going to be using that in the next few steps to solve more polynomials by factoring. So it says, what are the real or imaginary solutions of each polynomial equation? So here we've got x to the 4th minus 3x squared equals 4. In this case, we want to bring the 4 to the other side. So x to the 4th minus 3x squared minus 4 equals 0. To make this easier for us to factor, what we're going to do is we're going to create the variable a, and we're going to let that be equal to x squared. So instead of having it written like this, we're going to write it like this. We're going to have a squared, because a squared would be x to the 4th, minus 3a minus 4 equals 0. This we can factor much easier. So now we're just going to factor it. Two numbers multiplied to be negative 4, add to be negative 3. Well, that's a minus 4 and a plus 1. Now we're going to replace the a with the x squared. So we're replacing it. So now it's going to look back like what we were looking at before. So this becomes x squared minus 4, and then x squared plus 1 equals 0. This one I can factor again. This is the difference of two squares. So this is just going to become x plus 2, x minus 2. This one not factorable, so it stays x squared plus 1 equals 0. And so in this case, we just want to go ahead and solve this. So So now that we have all of that information, we're going to solve this. So I'm actually going to, so what we can do is we can solve this here. This becomes x plus 2 equals 0, so x equals negative 2. Here we add the 2, so x minus 2 equals 0, so x equals 2. So we got negative 2 and 2. And then this one, a little trickier, I'll bring it out here. X squared plus 1 equals 0. We're going to subtract 1, so x squared equals negative 1. We're going to square root both sides, and so that means x equals plus or minus, in this case, square root of negative 1 is just I. So our solutions here are negative 2, 2, and then plus or minus I. So here we've got x cubed equals 1. Let's go ahead and rewrite this by getting the 1 to the other side. So x cubed minus 1 equals 0. So here we should notice that this is the difference of cubes. X cubed is a cubed. 1 itself is a cube in this case, or negative 1. So if we take a quick look back here, we're looking at an example kind of like this. And so we're going to use this idea in order to factor this. All right, and so when we go back over here, we can kind of write it out. So we know a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And so ideally, we're going to go ahead and try to factor this out the best we can. So a minus b would be x minus 1, and then we're left behind with a squared, which would be x squared. And then a times b, that's minus 1x, and then b squared would be plus 1. Oh, sorry, this should be addition as well. Sorry, messed it up. All right, equals 0. Okay, so we have two quantities here. The second quantity, we actually can't factor that, so we're going to have to go back to what we saw before. If we want to figure out how this breaks apart, we'll go back to using the quadratic formula. So that would be negative 1 plus or minus the square root of 1 squared minus 4 times 1 all over 2 times 1. We're going to get negative 1 plus or minus the square root of negative 3 over 2. We can simplify this down to negative 1 plus or minus I square root of 3 over 2. So there's two answers. Then the last part of this would be to go ahead and answer this. So x minus 1 equals 0. So that means x equals 1. So right now we have x equals 1. And x also equals negative 1 plus or minus I square root of 3 over 2. The bottom part is practice. If you want to give it a shot, I recommend it. Some of these are easier than others. Like question C is already factored for you, so this one will be really nice and easy for the most part. Question B, a little trickier, but easily doable. And question A. So pause the video, give them a shot, and then unpause it to see the answers. So for the first one, you've got x to the fourth minus 16 equals 0. Because of that large quantity there, we can let a equal x squared to help us factor this along. So this becomes a squared minus 16 equals 0, which is the difference of two squares. We break it apart into a minus 4, a plus 4. We replace our x squared in both of those, and then from there we can either solve by factoring the one more or using our square roots. And so in this case we get x to equal plus or minus 2 for the first quantity, and then for the other one we get x to equal plus or minus 2i, because we're dealing with a square root of a negative 4, which simplifies down into 2i. All right, and then the second problem, B here, we're bringing over the 2x squared and the 8x, from which we can then factor out a GCF of x from all three terms. We're left with x times x times x squared plus 2x minus 8. That factors to x plus 4, x minus 2. We then set this equal to 0 for each quantity. Solve, you get x equals 0, negative 4, and 2. Question C, a little longer. In reality, I said it was factored already. It's actually not very helpful. We're actually going to distribute this back out because we need to know what we're working with. So x cubed plus 8x equals 8x plus 8. In this case, we'll bring the 8x over, so we've got x cubed minus 8 equals 0. This is the difference of cubes, so that means we've got x and then minus 2, and then here we have x squared plus 4x plus 4. Oops, made a mistake again. This should be 2x here. All right, there we go. And so this portion is pretty easy to solve. We get x equals 2, but here we would have to use the quadratic formula, which I can kind of write really small here. X equals negative 2 plus or minus the square root of, and we'll say 2 squared minus 4 times 1 times 4, really small, all over 2 times 1. So here we've got negative 2 plus or minus the square root of negative 12 over 2. And we've actually run into this a lot. This will simplify down. And so one of our answers is x equals 2. The other two answers in this case are going to be x equals plus or minus, or actually back that up, sorry. It's going to be negative 1 plus or minus the square root of, or I square root of 3. I'm missing a step. I square root of 3. And that's when you simplify all of this. I ran out of space. Here we want to talk about finding the real solutions of an equation by graphing. So first, let's get this set equal to 0 just to make things easier. So we've got x cubed plus 5 equals 4x squared plus x. We're going to bring everything over to the other side. So I'm going to subtract 4x squared, subtract x. So we've got x cubed minus 4x squared minus x plus 5 equals 0. All right, so now this is what we want to graph. So we want to go ahead and put that equation into our graphing calculator. So we've got x to the third power, so x cubed, and then we've got minus 4x squared, and then minus x, and then plus 5. And we're going to take a look at this graphically. All right, so there's our graph. So we're good. And so now we're looking for solutions. So we're looking for those zeros or those values where it crosses the x-axis. So to do this, we should remember we're going to hit second trace, take us to the calculate menu, option 2, zeros. And we want to go ahead and move our cursor. We're going to find these one at a time to the left of our first 0, and then to the right of it, hit enter. And it tells us that our first 0 is at negative 1.09376, so we can round it off if we need to. Then we're going to repeat this again to find the other zeros, so option 2. So now we're already to the left of the second 0 here, so I'm just going to move a little closer. So we hit enter, we're going to move to the right of it, hit enter, and we hit enter again. Our second 0 is at 1.1629 roughly, and we've got one more because we can see that there are 3 zeros in this case, so we'll hit second trace, option 2, and now we're going to move to the left of it. We're already to the left of it. We're going to move a little closer, and we hit enter. We go above it, we hit enter again, and our second 0 is at 3.930. We can round that as well. And so using the calculator, we can quickly find the solutions to this polynomial. And so remember, from our calculator, we got x equals negative 1.09, x equals 1.16, and x equals 3.93 roughly as our solutions to our particular polynomial here. All right, go ahead and try this one on your own in your calculator, see if you can do it without me. What we'll do first, though, before you do that, let's go ahead and rewrite this so we know what we're putting in our calculator. So we'll bring the x and the 1 to the other side. So we want this set equal to 0. So x cubed plus x squared minus x plus 1 equals 0. So now that we've gotten this written in the way we want it, now we can go ahead and put this in our calculator. We're going to put this in there. Put this in our graphing calculator, see if we can find our solutions, and we'll go from there. So if you put this in your calculator, you actually see that this graph does something slightly different than the last one. Let's say this is our graph. It looks more along the lines of, can't draw it here. More like this. And so we only have our one solution, or 1, 0. In this case, our 0 takes place at negative 1.84 roughly. So this is our only solution to this particular problem. Here we have modeling a problem situation. It says close friends Stacy, Una, and Amir were all born on July 4th. Stacy is 1 year younger than Una. Una is 2 years younger than Amir. On July 4th, 2010, the product of their ages was 2,300 more than the sum of their ages. How old is each friend on that day? All right, so we're going to go ahead and just let x equal Una's age. And so then we're going to start writing the problem in terms of the other one. So Una's age is x. That means in this case, Stacy is 1 year younger than Una. So Stacy equals, in this case, x minus 1. And that means Amir is 2 years older than Una, so he is x plus 2. All right, so we can set this up. So what we should recognize is they talk about the product of their ages was 2,300 more than the sum of their ages. All right. So if we take the product, let's say x times x minus 1 times x plus 2 equals, well, this is the product, and we know that it's 2,000 more than the sum, so let's go ahead and put 2,300 on this side, and then we're going to add the sum of their ages as well over here, so that way they're balanced. All right, and so this side we can simplify this down. We're going to get 3x plus 2,301. On the other side, we've got to do some multiplying. We've got x times x. We'll FOIL this out. X squared plus x minus 2. Distribute it out again. We've got x cubed plus x squared minus 2x equals 3x plus 2,301. We're going to go ahead and bring everything to one side because I'm going to actually use graphing to solve this. So I'm going to bring this piece to the other side by subtracting it. So I've got x cubed plus x squared minus 5x minus 2,301 equals 0. Okay, so now I've got my expression. And what I'm going to do is I'm going to use my graphing calculator, and I'm going to try to find the zeros for this function. And I'm just going to, this you can do in your calculator if you want, but I already know what it is. I know that in this case, my 0 takes place at 13. So right now, I already know that in this case, Una is 13. Stacy in this case is 12, and therefore Amir is 15. Here we have a similar problem, but this one's a bit easier. It says, what are 3 consecutive integers whose product is 48 more than their sum? So when they say consecutive integers, they mean one right after the other. So let's let the first one be x. That means the second one would be x plus 1, and the next one would be x plus 2. All right, so they're consecutive. So that means the product of this would be x times x plus 1 times x plus 2. And that we know that the product is 480 more than the sum, so that we're going to put the 480 on this side, and then we'll have the sum on this side. So we have product on one side, sum on the other. So product means multiplication, and then sum on the other side. All right, now we just need to kind of simplify this as we go. So we got x squared plus 3x plus 2 equals 483 plus 3x. We'll distribute this, x cubed plus 3x squared plus 2x equals 483 plus 3x. We'll bring everything to the left, so that's going to give us x cubed plus 3x squared minus x minus 483 equals 0. And so this, once again, is what I'm going to put in my graphing calculator, and I'm going to look for the zeros. And so once I put that in there, I'm looking for the zeros either graphically or from the table, and I get that my 0 in this case is at x equals 7. So what this tells me is that my first number in this case is 7, my second number is 8, my third number is 9.